WYM, short for Why Do You Match, is a new explainable artificial intelligence model, XAI, for the entity matching problem. The entity matching problem, EM, pertains to the task of identifying whether two textual descriptions correspond to the same real-world entity. The approach is usually modeled as a binary classification problem. The target class shows if the pair of the descriptions given as input to the model are matching or non-matching. Despite the number of approaches proposed in literature, many of them lack the capability to provide transparent explanations for their predictions. This is a problem that makes such approaches not usable in scenarios where users have to understand the behavior of the ML model. Many explainable systems have been proposed in the literature. Most of them are token-based systems, for example LIME or SHAP. These systems, which provide weights for the input tokens, measuring their impact in the prediction, can be ineffective in the EM scenario. In EM, we are comparing two descriptions, making the impact of a single token ambiguous. Moreover, these explainers can assign different weights to the same tokens in different descriptions, leading to confusion in their explanations. Furthermore, when dealing with large inputs, the resulting explanations from these systems are very large, as there is a weight for each token, thus making them difficult to manage for the user. To address the previous limitations, WYM uses decision units, DU. DUs are pairs of words from different descriptions, paired DU, or single tokens, unpaired DU, that signify the similarity or dissimilarity between two entities. The DUs are generated using an optimized stable marriage algorithm applied on BERT word embeddings. WYM uses DUs to more accurately evaluate the descriptions in a dataset and decide whether or not they correspond to the same entity. WYM's key innovation is the use of DUs to provide explanations for the model's predictions. Unlike other well-known post-hoc explainability approaches like LIME and SHAP, which offer explanations for black box models, WYM is intrinsically explainable because the model's weights provide insight into the decision-making process, resulting in precise explanations for its predictions. The figure shows the architecture of WYM and showcases two examples of entity descriptions derived from a dataset of songs. The initial phase of the process is dedicated to generating the decision units, which are then fed into a neural network to obtain the relevant scores. The scores serve as the basis for extracting the features that are subsequently used to predict the match or no match. Additionally, an explanation analysis tool has been integrated to generate counterfactual instances and identify the decision units that contributed the most on the prediction. This Jupyter notebook presents a comparison between LIME explanations and WYM. After importing the necessary modules, BERT is initialized using the iTunes Amazon dataset to generate word embeddings. Subsequently, WYM is used to compute predictions and the impact of decision units. For the sake of simplicity, the same example shown in the architecture figure is utilized. The first figure illustrates the explanation from LIME, which quantifies the influence of tokens from the left and right descriptions. Below, a bar plot generated by WYM shows the impact of decision units on the prediction. For example, the presence of the same song name in both descriptions results in a significantly positive impact, whereas mismatches or typographical errors generally have a negative impact. With respect to counterfactual examples, this Jupyter notebook demonstrates that the results of WYM's evaluation after the application of various perturbation strategies can be filtered to identify those samples whose prediction differs by more than 50%, indicating a change in class. The best examples are selected as those that minimize the number of decision units removed, highlighted in red in the table. WYM can also evaluate negative examples using the same approach, as illustrated in the following table.